Hello, today I will speak about the quadratic function definition. A quadratic function has the general form y equal x squared plus bx plus c, where a quadratic coefficient controls opening and shape, b linear coefficient shifts vertex left right, C constant term shifts graph up down. So a quadratic coefficient controls opening and shape. B linear coefficient shifts vertex left right. C constant term shifts graph up down. Shape of the parabola when a bigger than 0 opens upward has a minimum. When a smaller than 0 opens downward has a maximum. How coefficient affect the graph? Coefficient affect a bigger than 1, narrower, steeper curve. A bigger than 0, smaller than 1, wider, flatter curves. B, when B moves vertex left, right. When C moves graph up and down. Vertex turning point. How we can find vertex? We can see here from the formula. This is, we can find the vertex when we find x here and write it instead of x in the equation. The first example is upward opening. I have this equation y equal x squared minus 2x plus 1, and when I factorize this equation I will get x minus 1 multiply with x minus 1 equal x minus 1 square. To get the vertex, first I know minus b, it will be minus 2, b minus 2, and 2a equal 1, and I will get minus 2 instead of b. 2 by the coefficient of x squared is 1 by 1 equal 2 divided by 2 equal 1. So x equal 1. And how I get the vertex, I will change, I will write x value in the equation when x equal 1, and I will get the vertex. I can do it here. Y equal 1 square minus 2 by 1 plus 1. Y equal 1 minus 2 plus 1 equal 1 plus 1 equal 2 minus 2 equal 0. So the vertex is vertex equal, or when x equal 1 and y equal 0. And the symmetry line equation x equal 1. Now I will use the table and I will use very low values to x, and I will draw the parabola here. When x equal 0, e equal 0 square minus 2 by 0 plus 1 equal it will be 0 here and y equal 1. So the first, when x equals 0, y equal 1. Then I will choose when x equal 1, and this we did here, so I don't need to do it again. So I can, I have it now, the vertex. So 1, when x equal 1, y equals 0. Then I will take minus 1, y equal minus 1 square here, x minus 1, and I will write it here, 2 by minus 1 plus 1. Y equal, when x equal minus 1, y equal, I will calculate it, minus 1 by minus 1 equal 1, minus 2 by minus 1 equal plus 2, minus 2 by minus 1 plus 2, plus 1 equal 1 plus 2 plus 1 equal 4. When x equal 1, y equal 4. And when x equal 2, y equal 2 square minus 2 by 2. Instead of x, I write the value I choose to x. Then I will find the y value. 4 minus 4 equals 0, and it will be equal 1 here, because y equal 2 power 2 equal 4, minus 4 plus 1 equal 1, and when x equal 2, y equal 1. Then I will take when x equal minus 2, y equal minus 2 power 2. Instead of x, I will write minus 2 and minus 2 by minus 2 plus 1. Here, minus 2 by minus 2 equal 4, minus by minus plus, minus 2 by minus 2 equal plus 4 or plus 1, 4 plus 4 plus 1 equal 9. So when x equal minus 2, y equal 9. Now I will draw the parabola, the curve. I have 0, 1. When x equals 0, y equal 1. When x equal 1, y when x equal 1, y equal 0. When x equal minus 1, y equal 4. When x equal 2, y equal 1. When x equal minus 2, y equal 9. When x equal minus 2, y equal, if I said here, maybe, I didn't, more than here. This is 7, 7, and 8, 9, so it will be higher, maybe here. And the parabola or the curve look like this. And we see the vertex here, 1, 0, and the symmetry line when x equal 1, x equal 1. And here, because we have an repeated root, so we have just 1, 0, 0. Vertex turning point always lies on the on this line. This is turning point, and it lies in this line, symmetry line. The symmetry line divides the parabola into perfectly symmetrical halves. This was the first example, upward opening, and when we look at this at A coefficient here is 1, which is bigger than 0. It's 1 here, and we see the parabola look like open word, so here smile face, and we have minimum. The second example, when downward opening, and when I look at the equation y equal minus x squared plus 2x plus 3, I will draw at the same way. I will draw the parabola, and I will choose x values before that, but I will factorize this. I will change minus equal before I factorize, so I will multiply it with minus 1, and then I will write 0 instead of y. Minus 2x minus 3 equal 0, and I will, when I factorize the equation, I will get, and here when I factorize this equation, x by x plus, I need minus 3 here, and minus 2 plus 1 minus 3. And I know the zeros is x equal x plus 1 equal 0, x1 equal minus 1, and x minus 3 equal 0, x2 equal 3. So when y equals 0, x equal 3. When y equals 0, another x equal minus 1. So two places the curve will interest the x-axis or go again on 2 points when x minus 1 and y equal 0, and when x equal 3. Now I will choose a value to x, and then I will draw the curve or parabola, and I will begin with when x equal 0, y equal minus 0 square plus 2 by 2 plus 3. Not 2, because I choose when x equal 0, so y equal 3. So when x equals 0, y equal 3, exactly this point. And when x equal 1, y equal minus 1 square plus 2 by 1 plus 3, and here minus 1 because this 1 by 1, and I will get here y equal minus 1 plus 2 plus 3 equal 4. Then when x equal 1, y equal 4. when x equal 2, y equal minus 2 squared 2 squared plus 2 by 2 plus 3, and y equal this is 2 squared equal 4 minus 4 plus 4 plus 3 equal, this is, it will be 0 minus 4 plus 4, and I will get y equal 3, so 2 3 when x equal 2, y equal 3. When x equal minus 2, y equal minus 2 squared plus 2 by minus 2 plus 3. This y equal minus 4, because minus 2 by minus 2 equal 4, plus, and I have minus here outside the brackets, plus minus equal minus 4 plus 3, minus 4 minus 8 plus 3 equal minus 5, and now I have minus 2 minus 5. Then I have the last value. I will choose, I forget minus 1, and minus 1 I have it here. I don't need to calculate it, because when x equal minus 1, y equal 0, so I will not calculate it. The first when 0 equals when x equals 0, y equal 3, this one, and when x equal 1, y equal 4, this will be here. I go up here from 1, and this, and when x equal 2, y equal 3, when x equal 2, y equal 3, it will be here. My one here, okay. And when x equal minus 2, y equal minus 5, and it will be here. And when I draw the parabola or the curve, it look like this, and I can see the symmetry line when x equal 1, and I get it, and I can also calculate it by use x equal minus b divided by 2a, x equal minus b, I have minus 2 divided by 2 by 1 by minus 1. X equal 2 divided by 2 equal 1. So the symmetry line equation x equal 1. And this line divided the parabola into two perfectly symmetrical halves, and the vertex is here when x equal 1 and y equal 0, vertex. And the vertex is turning point always lies on the symmetry line. And we look 1 2 step here, 1 2 step here. This is 0 0. and the equation begin with minus x squared. It means a smaller than 0, and we see the face is sad face here. So we have maximum point. Now is the third example when the parabola is narrow and a bigger than 1. When we look at the equation, we see a equal 2, bigger than 1. Steeper curves opens upward, and now I know when x equal 0, y equal 0. So the 0 x equal 0, and x equal minus b divided by 2a. There is no b, and the symmetry line equation equal x equal 0. When x equals 0, y equal 2 by 2 square equal 0. So 0, 0, x 0, y 0. When x equal 1, y equal 2 by 1 square equal 2. So 1, 2. When x equal 2, y equal 2 by 2 square equal 2 by 4 equal 8. So when x equal 2, y equal 8. And when x equal minus 1, y equal 2 by minus 1 square, or minus 1 by minus 1 equal 1. So the 2 by 1 equal 2. So minus 1, 2. When x minus 1, y equal 2. And when x equal minus 2, y equal 2 by minus 2 squared. And this equal 4. 2 by minus 2 by minus 2 equal 4 equal 8. When x equal minus 2, y equal 8. Now can I draw the line, and I know the x is x equals 0, and when x equal 1, y equal 2. When x equal 2, y equal 8 here. When x equal minus 1, y equal 2. And when x equal minus 2, y equal 8. So, and when I draw the curve, it looks like this, and it opens upward, and the maximum lie on the 0, 0 point. When and the symmetry line x equals 0, and the vertex equals 0, 0 in this. And we can see the curve is very narrow when a bigger than 1. Example 4, or the situation 4, when the curve is wide, the parabola is wide, flatter curve, a bigger than 0 but smaller than 1. And when we look at this equation, y equal half x squared, no, 0.5 squared, and here also the zeros equal x equals 0, and the symmetry line also lie on the y-axis, y-x. Yeah, so axis equal axis x equals 0, and the 0 x equals 0. Yeah, and when x equals 0, y equal 0.5 by 0 squared equals 0, so it's 0, 0, and x 0, y 0. When x equal 1, y equal 1 half, or 0.5 by 1 squared equal half. So when x equal 1, y equal 0 half, and when x equal minus 1, y equal 0.5 by minus 1 squared, and this will be positive because minus 1 by minus 1 equal plus 1, and the results 0.5. So when x equal minus 1, y equal 0.5. When x equal 2, y equal 0.5 by 2 power 2, and equal 2. So when x equal 2, y equal 2. And when x equal minus 2, y equal 0.5 by 2 minus 2 squared equal, this will be positive because minus 2 by minus 2 equal 4 by and half equal 1 half, a half by 4 equal 4 divided by 2 equal 2. So when x equal minus 2, y equal 2. Now I will draw the line, the curve, and I have 0, 0 here in the middle, and 1 when x equal 1, y equal half. When x equal minus 1, y equal half. And when x equal 2, y equal 2. When x equal minus 2, y equal 2. And when I draw the curve, I can see it look like wider than example 3, when it's a more or bigger than 1. Now a between smaller than 1 and higher than 0 or bigger than 0. So and the symmetry line, this line y are the symmetry line divided the curve to halves, perfect perfectly symmetrical halves. And this is the vertex, 0, 0, and the symmetry line equation x equals 0. The last example, the fifth example, example number 5, and I will finish after that. Shift it vertically. 5, and shift it vertically. Equation y equal x power 2 minus 3. Same shape as y equal x squared, but moved down by 3 units, by 3 units. Then I will write it. And I will draw a parabola, a curve here, and I will choose x values, and I'll always begin with when x equals 0. X's equal 0, x equals 0. And the two roots, x minus root 3 or plus root 3, and it will be 1.7, minus 1.7 or plus 1.7. When x equals 0, y equal 0 square minus 3, so y equal minus 3, so 0 minus 3, and it will be here. When x equal 1, y equal 1 square minus 3 equal minus 2. So when x equal 1, y equal minus 2. So it's here. And when x equal minus 1, y equal minus 1 square minus 3 equal 1 minus 3 equal minus 2. So when x equal minus 1 and y equal minus 2. When x equal 2, y equal 2 square minus 3 equal 4 minus 3 equal 1. When x equal 2, y equal 1. And when x equal minus 2, y equal minus 2 square minus 3 equal 4 minus 3 equal 1. So when x equal minus 2, y equal 1. So it will be slide like this. And now I will draw the curve, and it's look like this, and it's minimum point, and x equals 0, and the vertex equal 0 minus 3. The 2 points here and here, this point as plus root 3 or 1.732, and this look like 1 minus 1.732 or minus root 3, and it's when it's shifted vertically x minus 2, we see here the constant minus 3 here when x equal 0. I hope it was a good lesson for today. We can meet in another lesson. Bye bye.